Segmented wood turning is not new. A lot of people are doing it. They have their own way of putting it together, which is just fine. But I'd like to share with you my technique of putting the project together by reproducing this piece that you can see. Uh, Most likely with different woods, different colors, but the shape is going to be pretty much the same, and the contrasts are going to be there. So we'll work on this piece from beginning till end, and hopefully you'll enjoy it. And if you like some of the things that I made to help me, feel free to go ahead. That's how we share. The type of choice of lumber is going to be important. To allow this vase to stand out, as you can see, you have the two colored woods, which is basically a light color versus a dark color. If we were to keep the segments closed all without any partitioning, it's like it's like installing tiles and sort of masking them with a grout that will make them disappear. So by having this even with one type of wood, it'll make this look dull. It'll make it look plain. This way, with the partitioning, all the segments show up. It's like you see the building blocks of the vase. And I find that is a lot more attractive than just having one color. So each segment, notice that it fits exactly where the curve ends. There's no extra. There's nothing missing. So you waste the minimum amount of lumber. To follow the same level of accuracy as I designed, I've built a couple of jigs that allow me to do just that. One of them is a faceplate, and the other one is a what I call a squaring tool, which eliminates pretty much all sanding and reduces the dust and gives you very accurate flat surfaces. This is the cutting jig that I've designed for cutting my segments. It's made of aluminum. Um, it's stable. It will not bend or twist. It's designed for 16 segments. The stop for the segment is this part here. The lock is there, and you have a fine adjustment in either direction. Two clamps to hold the segments in place while we're being cut, so that we keep our fingers in good order. And also, I've put in two stops that go into the slots of the table saw that will prevent the whole jig from moving more than it has to. Now I'm going to show you basically how you hold the segments in place using this jig. It holds this way, put down the blades, put in screw. Now it's locked in position. The blade cuts the wood and it'll remain in its position after it's cut. So you're safe with your hands. We'll begin with the strip for the segment number 2. There we go. And let's cut our piece. I can now label this as strip for segment or ring number 2. So basically I put in a number 2 and prepare for ring number 3. All the strips are basically similarly cut. It's just a question of the width and the length. Okay, time to cut. So I'm locking it down now. Turn on the dust collector. Turn on the blade. And we cut our make our first cut. Now we rotate. Again to stop. Lock it on both sides. And I'm looking for 0.832 of an inch. And I am measuring 0.849, which means I'm off by about 17 thousandths of an inch. That corresponds to about, I'd say, close to 1/3 of a turn of my wheel. Now I loosen the wheel and go forward about 1/3 of a turn, lock it, and let's start the next piece. Okay, we'll turn on the You notice that I cut the piece very slowly. In order to be consistent, you gotta cut it slowly and consistently, which means every piece should be cut at that speed. Somehow it does affect dimension accuracy of the cut if you cut erratically. So try to maintain the pace the same. Okay, now let's measure the piece we just finished cutting. Remember, we're looking for 0.832. I have 0.836. I'm very close. So now I just have to twiddle a tiny bit of the wheel, and that should do it. Let's do another cut. It's not, it's not really that critical to be that accurate. But what I'm saying is we have accurate tools. We have accurate adjustments. Let's aim to be as close as possible, and that will give us a ring that can predict to within 1/8 to 1/16 of an inch accuracy. So why not? Now that I have finished cutting the 16 segments, we will proceed to assembling these segments into the ring required. Now that the pieces are cut, we will sand down these whiskers and glue our decorative edge band or piece on it.
Take the glue away. Perfect. Here we are.
Okay, all the pieces have been glued. Now we're ready to trim this edge to make them consistently 1/16 inch wide. But when we are ready to recut this piece to the size mentioned on the drawing, there we have to make sure that our width here is the correct width. So let us proceed. I set the piece up so that the trim is about 1/16 inch away from the edge. So we'll be cutting off just this much. So obviously on the other pieces, they'll all be trimmed to that 1/16 inch edge. Now I fixed it. The piece is clamped down. I'll bring over the stop and lock it in position. Okay, now we are ready to cut. It's all set up. Let's turn on the saw. These pieces have now been cut. We now have to trim or retrim the pieces to the correct size, which was, if you remember, the 0.832 inches. Now we have to trim this piece the amount of material that we've added. In other words, from here to the end point should be 0.832 as we did in the beginning. Bingo, we're right on. We're about 2,000 inch bigger than it should be. It's well beyond our accuracy that we need, so we're good. And we will use a piece of paper at the bottom for two reasons. One reason is obviously I don't want to dirty the saw or the table with glue. For the other reason is it will be an interface between it and the centering of the ring onto the faceplate for centering. Glue on this container just to speed up the gluing process. I start with one piece left as is and two pieces at a time. Dip. So take these two, dip and moisten. It's better to have a bit more glue that needed than not having enough. So, but nevertheless, when you're gluing rings, you want the rings to be able to slip with one another as you clamp them. This way they'll center each other automatically. The paper remains as part of the glued up piece. There's a reason for that, and that will be used to separate the ring from the disc that I will be using to center and eventually glue onto the growing vase as it grows. Okay, now this ring is finished, so push this on the side, and I'll show you the balance of the rings have been completed, and this is going to be the base. This one is ring number 2. You notice the paper is still on. Ring number 3. Number 4. Number 5. Number 6. And number 7. It is now time to center the rings onto a faceplate that will be used to flatten the surface of the ring and also to glue onto subsequent rings or the base. I will use a pair of calipers to center it. So eyeball it in the beginning and then check the distances. It's too long, so shorten a little bit at a time until the ring stops moving. Still too long. Very good. Now let's check the other direction. Try again. Make sure the rings don't move. Right now it's still moving. slightly too long. Okay, just draw now, bring it down a bit. Excellent. I have the distance, it's not locked in position, the distance between the edge of the ring and the edge of the faceplate. Now this faceplate is very round and very well balanced. So now that I have this, hold on to this. I'll use white glue, wood glue. That should be enough. Put it centered the best as you can. And then use the setup, the distance to center it. That's it. Now gently press on it and let's set for about 1 hour. Obviously, the next step is to flatten the surface of the ring. There's two ways of doing it. Either we sand it down or we cut it. In cutting, if you're doing it by hand, you have to be very careful to arrive at a flat surface. I have instead developed a tool or a guide that will allow us to do just that. So instead of creating dust, we create shavings, and the surfaces come perfectly flat. Now, we are ready to assemble the vase now. We must obviously start with the base, which is composed of one solid piece of walnut. And to this base, I attached a piece of maple that will serve as a waste block to support the vase during the turning process. It is already centered, so this center will be maintained all the way through the end. Now this is the piece in question. That's the base. In the end, it will be shaped as you see here. The next piece to add to this would be ring number 2, which is this ring. And as you will notice, I have crossed or marked every edge, every segment. That will allow me to know that when I'm facing this segment, this face, I will know that once all the lines have disappeared, the ring is now flat. Okay, we're ready to prepare the piece. I'll be using basically friction drive. Now I opened up the jaws all the way to maximize the contact, and nice and strong. Okay, we are now round, and I'll be giving it a dovetail to accommodate in my chuck. Okay, now you put the base in, you tighten it very hard. It's nice and tight. Once installed on the chuck, this piece, along with the whole vase, will not be separated from the chuck. We don't want to lose the center. Every time you take out a piece from the chuck, you'll always lose the center. You'll be close, but you'll never be dead on. So these two parts remain attached until the end. Now that the piece is installed and it's ready to be assembled, we have to start by flattening the surface. Now, most people, what they'll do is they'll probably turn to the best possible flattening that they could visually, but then they will all have to end by sanding. I did a lot of sanding. One of the problem is that it creates a lot of dust. So I've invented a tool that will allow me to actually trade dust for shavings. It's very accurate, very efficient, and it does the job beautifully, as you will notice soon. Now, one way has a very nice adapter that attaches to their tailstock. And with this adapter, you could attach face plates, you could attach chucks, and you've got now two holding items that are centered. So when you're combining or gluing the rings together, you don't have to worry about centering. All you have to worry about, where do you glue? I'd like to introduce you to a tool that I invented to actually square the surfaces. It replaces the tool rest. What it is a flat bar, 1/2 inch by 2 inches. This is used to carry the cutter. It's sitting on a nylon slide with an adjustment screws for this type of play. I purposely had given a small movement so that I can clear the wood when I finish cutting. When I come back, you will see. I have the cutting tip is a carbide tip. It will be advanced by this screw advancement, and I have 2 screws here to adjust for the tightness of the tool. This has been conceived so that it only advances. You cannot come back with this. To come back, you loosen the screws and you push this back. Okay, we are now going to square the slide bar with the bed. The way to do it is simply move the faceplate next to the slide bar and just move it forward and watch this gap go down to 0. I'm actually twisting it towards the faceplate as I do so until they're both 0. There you go. Now I lock my bar, get rid of the tailstock, and now my cutter is square to the bed. So when I cut against the face, this face will be square to the bed, and that will be perfectly flat. Okay, I will mark the surface with pencil. So when all the pencil marks are gone, then we know we're flat. Okay, the faceplate has been installed on the lathe. We're going to set up the slide square to the bed. There you go. We still have pencil marks. All the pencil marks are gone, but I went a little fast on this last cut. So I'm going to repeat the cut with a slow motion. Well, I made a nice smooth surface because of the slow motion in cutting, and no no sanding is required. So both surfaces can now come together. We will replace the faceplate with the chuck that contains the base. We'll mark the circumference so we don't have to use, we don't have to put glue where it's not necessary. Now, once the glue sets, which will be probably approximately half an hour, I can actually pull this apart. The paper that's here will separate, and we're ready to continue on the next process. When this is done, and you separate the chuck from the faceplate, this is removed, the chuck is replaced in place, and the process begins again with the flattening of the disc and preparing the next ring the same way. I've assembled all the rings. You have a ring separator, ring separator, ring separator, ring separator, and so on, right up to the ring number 7, where we'll be adding the separator for the next ring. Now this is the glue up of the last ring and the top of the vase. We'll be separating it now from the faceplate to prepare it to glue up for the rest of the vase. The leftover paper can be scraped off with a scraper that has a clean, sharp edge without damaging the arborite that was glued on the surface. And this allows the faceplate to be reused over and over again. We'll transfer the work in progress on the lathe. Here we're ready to start shaping the vase. I'm going to put it at approximately 1,000 RPMs. Now all the low spots and the high spots have to be rounded off, which means all the corners due to the segment must all blend in. And you maintain the curve of the vase according to that. Now in this area here, you will find that the high spot is there, the center of the low spot is somewhere here. So it's a matter of blending in the two together. It's like drawing a picture using numbers. You join points to points to points to points, and that gives you the shape. So there's no guesswork. There's no errors. Now follow the curve. You'll notice, see, there's a straight edge here. It means that the curve here hasn't been followed. So it's a matter of getting rid of the wobble here, which is the corner. That has to disappear. And I'm preparing here for that cove. At this point in time, the curves have to be maintained. The design of the vase have been shaped this way. The best thing you could do is join the points together, curve them correctly, but you cannot change too much the shape because it wasn't designed for it. If you do so, you risk going through the vase or creating thin walls that you don't want to create. But the biggest danger is you may go through. So stick to the plan. All right, the vase has been turned. This is the finished product. I'd like you to I'm going to give you a little summary of what we have just accomplished. You'll notice that none of the layers were sanded, so no dust was created. Each piece or each ring fits on top of each other in a way whereby everything is lined up, everything is centered. In turning, very little material needs to be removed. All we have to do is just turn the high points to the low points and so on. It's like joining the numbers together and as if we were drawing a shape using numbers. So basically, if you cut the pieces precisely, join the pieces precisely, you have less wobbling on your lathe, which means less material to be removed, and the shape is already there. By just joining the corners, the shape is there. It appears, it comes out. All we need to do is basically refine the cut, smooth the joints, and make sure that there's no scratches. And so that's why I did not concentrate much in this video in the actual turning, but mostly on the process, the procedure in putting it together. So we use the lathe to center the rings so they don't wobble. Plus it allows the rings to be glued without any shifting. And we use the tool that I invented to flatten each ring or each face that needs to be glued. And again, that removes the production of dust. And all in all, because of the precision and because of that method of assembly, little material is wasted, little material is removed, and you get some really nice, easy shapes that makes it excessively easy to shape. So we don't have to guess. It's all there. just have to join the points.